symbol for inches. And this is a H and this is a G. Huh? Mercury, yeah. This is the chemical symbol for mercury. So it's saying mercury. What do you guys know about mercury?
It's not a metal or a liquid. It's, yeah.
Mercury?
No, I don't know too much about mercury.
Mercury, Caesar? Your vast experience? First planet from the sun. Old car model, yeah.
Old car model.
Poisonous, yeah, very hazardous to you, yeah. Mercury poisoning when you eat enough certain kinds of species of fish, they say, watch out.
It's like it's in lead. It's like a metal
It
lead.
is a heavy metal. It is a heavy metal.
Affected by temperature?
Yeah, mercury is unique in the fact that I think it's only 1 out of 2 elements that are liquid at ambient temperature. So it's in a liquid state. So what your scale is reading is if I put vacuum and I have a column of mercury, all right? This is all filled with mercury, and at atmospheric pressure, I got 30 inches of mercury, okay, in this atmosphere, Earth's atmosphere. Now I put a negative pressure, I put a vacuum on it, and I collapse, I compress this column of mercury down. And I compress it down to Jimmy's value of where he said I like vacuum at 2 inches on my condenser. That means my vacuum, my negative pressure, has been able to pull that column of mercury down 28 inches. Okay? And hold it there. So that's how strong this vacuum is to pull that column of mercury down. What's the other interesting thing about mercury compared to water? It's much heavier. It's much more dense. So, you know, to pull that column of mercury down that amount is creating a very strong vacuum. So can I read this scale both ways? Can I say he is 2 inches from being at the most strongest vacuum that I can make? This is the strongest vacuum that I can make on this planet. 30 inches of compression. Can't do any better. Can't get a stronger vacuum than that. And that's just the law of physics. So can I read this scale as this 0 representing absolute best? I can say I've got 2 inches of mercury, but I put an A behind it and I say absolute. Meaning that I'm reading from the very perfect score. I'm getting 2 inches away from being at the best. Easy way to read it, right? If I go from 2 to 3, what has happened? I got less vacuum, yeah. My vacuum has degraded. It's not as strong. But I can read it the other way, right? And if I went from 30 inches of mercury down to 2 inches, I could say, what is your vacuum? 28. Without the A, without the absolute behind it. That's telling you that I'm coming from the value of 30 and I'm reading the pressure like that. Okay, what if I told you in your power plant, you've probably got vacuum gauges that are both of these styles? And the key thing would be, you're gonna have to look at the nomenclature to see if it's saying inches of mercury or inches of mercury absolute. To really know what value you're assessing. Is that true? Do you guys go take readings and get different readings? Yeah. Okay. What if the reading was 15?
You wouldn't be online. Phew.
No matter which scale you're reading it
Yeah,
from,
you gotta work hard.
the bottom best to the other, least, it's gonna be equivalent, right? So, what are some of the things? Why does the operator focus so much on his vacuum reading in the condenser?
That's your efficiency of your turbine.
Right, very good. I want to make the best vacuum that I can, and guess what will be the trade-off for that best vacuum? I'll get the higher generation and be at my most efficient stuff. What other things? What other things makes him drill that eyeball down on that?
It doesn't build pressure?
Anti-gas removal.
Well, all of those things can affect it, but what is, again, from the protective side of the turbine, what does the vacuum?
Lower room down, cause
Yeah.
a trip.
Yes, correct.
8, 10,
So different settings, you've got a high condenser vacuum interlock, right? It's an interlock trip, and it's going to stop the turbine at that preset value, right? Okay.
Wait,
What would be the way to find out what your interlock settings are? Anybody know any good reference material or good, easy, handy guideline? Because if not, I'll give you one. In the turbine manuals,
Yep.
you should have a set of very large books, almost like encyclopedia dictionary thickness books in your facility. And if it's a Mitsubishi turbine, it's gonna be a black manual with a red diamond on it. And a Fuji, I don't know, what color are they, Troy, like blue or something?
Blue, maybe blue.
Baby blue, yeah, okay. In there would be a section that's gonna say limit of operation. So it's gonna give you a very condensed chart table that's going to give you alarm and trip points for depending on whatever the protection is set at. So it'll give you a certain point where it says, hey, you're in an alarm condition, this is abnormally high. Or it's going to